Hello students, in today's class we will be discussing a problem on isometric projection. In isometric projection, we will be looking at a solid in such a way that all the three axes, that is x, y and z axis, will be equally inclined to each other. So in such a position, all the horizontal edges will see as shortened when we are looking from the front. So the actual dimension will not be visible when we are drawing the views. So we have to find out what will be the new measurement of the actual length. For that, we have to construct an isometric scale. So from the isometric scale, we have to find out what are the shortened dimensions. And that is, all the horizontal edges will be shortened, whereas the vertical edges will have the same dimension. Now, while drawing this, we are drawing in such a way that all the vertical edges are drawn vertically and all the horizontal edges are drawn at an angle of 30 degrees to the base. So this rule has to be followed. So all the horizontal edges are drawn at an angle of 30 degrees to the baseline and all the vertical edges are drawn vertically itself. Now there can be two questions. Either you will be asked to draw the isometric projection or an isometric view. So isometric projection is the one which we are drawing using the shortened dimension, or what dimension will be visible to our eyes. Whereas for convenience, we may draw the drawing to actual scale. So such drawings are called isometric views. And in isometric projection, we have to convert all the dimensions into iso length, or we have from the isometric scale, we have to find out the iso length. Now look at this question. In this question, you are asked to draw the isometric projection of a rectangular lamina. Lamina is nothing but a sheet of negligible thickness. So it is rectangular in shape. You can assume it as a sheet of paper. So the dimensions are 30 by 60 mm. Now the sheet can be either vertical or horizontal. Why we are doing this problem is that, see, if you look at a square prism, you can see that the base and the top, they are square, whereas the four sides, they will be rectangles. So it can be split into two square laminas plus four rectangular laminas. So the combination of these six laminas will give you the isometric either view or projection. So in this question, you are asked to draw when this lamina is in a vertical position, and the second case when it is in the horizontal position. So first of all, you have to construct the iso scale. Why? Because you are asked to draw the isometric projection. So the method of constructing the iso scale is, first draw a horizontal line, then draw a line inclined at 30 degrees, another line inclined at 45 degrees. So first line is inclined at 30 degrees, the other is inclined at 45 degrees. So in this case, the top line, which is at 45 degrees, will give the true length, or in that line we are going to mark the dimensions. For example, in this case 30 and 60 we will mark over the true length line, and from those lines we will project vertical lines to the line inclined 30 degrees, and that measurement will give you the isometric length. For example, let us mark 30 mm. So from the tip you mark OA in such a way that that length is 30 mm. So from that point you drop a vertical line to the isometric length line, or the 30 degree inclined line. Then OA dash will give the iso length corresponding to OA. That is, OA was 30 mm, then OA dash will be less than 30, which will be 81.6% shortened. So if you multiply the actual value by 0.816, you will get the isometric length. Similarly, you mark a point B such that OB is 60 mm, and from that point you drop a vertical to the isometric length line, and OB dash will give the iso length corresponding to OB. So this is how you are going to find out the isometric length. Now this is a solid, or this is the lamina of side 30 mm by 60 mm. Now we are going to draw the case when it is vertical. So when it is kept vertical, you can see that one of the sides will be on the base. So let us take, say, 60 mm side, let be on the base. Then you can see that the other two sides will be vertically up and the other one will be horizontal. So let's draw the case when the lamina is vertical. Now for that, first we'll draw a baseline which is identical to our xy line. So draw a baseline and you locate any one point in this lamina. So let us pivot the point A. So mark a point A on this baseline, and from that you identify the edges. You can see that AB is horizontal, DC is horizontal, whereas AD and BC they are vertical. So our rule is all horizontal edges should be drawn at an angle of 30 degrees to the base, and all vertical edges should be drawn at a height of or should be drawn vertically. Now, since the question is isometric projection, you have to convert these dimensions into isoscale. So you find out the isometric length corresponding to 30 and 60. Now, you can directly plot this from this scale. You can use a compass for that. Now I have pivoted the point A. So from the point A, I am going to construct the rest of this solid. Now you draw a vertical line representing AD whose length is equal to iso length of 30. So you can mark the point D. So AD is equal to iso length corresponding to 30. And it is drawn vertically since our rule is all vertical edges are drawn vertically. Now draw the base edge AB at an angle of 30 degrees and the length is iso length corresponding to 60, and I'll mark the point B there. And from B, BC is vertical, so I have to draw the line BC as vertical itself at a length of iso length of 30. Now the closing ends, you can directly close CD or you can draw a line inclined at 30 degrees from the point D. So I'm just joining DC. So this will give you the isometric projection of this lamina when it is vertical. Okay, usually capital letters are used for labeling the isometric figures. Now let us take the case when the solid is or when the lamina is horizontal. Now when it is horizontal, there are no vertical edges. Assume a paper lying on a floor. So it doesn't have any vertical edges. Unless you are keeping it vertically, it will have only, or if you are keeping it vertically, it will have two vertical edges and two horizontal edges. Now if you are allowing that paper to lie on the floor, all the edges, whether it be AB or BC, they all will be horizontal. So our rule is horizontal edges should be drawn at an angle of 30 degrees to the base. Now let's see how we can draw that. Now draw the baseline and locate the point. Here also I am locating the point A. Now AB should be drawn at an angle of 30 degrees since it is horizontal. So I am drawing AB which is at an angle of 30 degrees. Now the edge AD, it is also horizontal in this case. So that should also be drawn at an angle of 30 degrees in the opposite direction. So I am drawing AD at an angle of 30 degrees from the point A. Now the next edge which is DC. So that is also horizontal. So from the point D, you have to draw a line inclined at 30 degrees. So the easy method is you can roll the line AB. So you can use a combination of two drawing tools, a set square and a scale, or if you're having a roller, you can use that, and you move the line parallel to AB and locate the line from D, or the other way is you can draw a short line at D parallel to the base and measure the angle 30. So but moving the line will be easier one. It will be easy for you to save time and locate the point C. Then you join or close a figure CB. So this will give the isometric projection when the lamina is horizontal. So if you are having this orthographic view, you can label all the dimensions in the orthographic view itself, or else you have to draw the dimension on any one of these isometric projections.